All right, so we're on assignment number 7 for Unit 12, which is on permutations and combinations. Let's go ahead and get started. What is a permutation and a combination? Let's just give you two examples here. Suppose you are selecting first, second, and third place prizes for the year from a class of 24 students, and you want to give out awards. You're like a teacher and you want to give these awards. And so what we could do is we have three different possibilities here, or three different awards to give away. We have 24 choices for our first place prize. So that's 24. Then once we pick our person who's going to get first place, then we have 23 left for second place and 22 for third place. And so we could just simply multiply those together. Another way to do that, though, is to take 24 factorial over 21 factorial. Remember, 24 means 24 times 23 times 22 all the way down to times 1. Well, 21 factorial would be 21 factorial times 20 times 20 and times 19 all the way down to 1. Well, 20 through 1 would cross off 20 through 1 down here, and I would be left with 24 times 23 times 22. Another way to do the same problem is to do a permutation where you're picking from 24 students, you're picking 3, and you're putting them in order. And that's a key here. Permutation, order matters. Similar situation that involves a combination would be something like this. Suppose you're just going to select your top 3 students from your class and give those 3 students, let's say, a certificate, an award certificate. So again, you would have something like this. You would have 24 for the first person you chose, 23 for the second one you chose, and 22 for the third one that you chose. However, let's say you pick, I don't know, Al, Bill, and Chris. Well, if you pick Al, Bill, and Chris and give them certificates, then it wouldn't matter whether you picked Al first or Bill first, or Al first or Chris first. These 3 people could be on this list really 6 different ways. It could be Al, Bill, Chris, Al, Chris, Bill, Bill, Al, Chris, Bill, Chris, Al, or Chris, Al, Bill, and Chris, Bill, and Al. In other words, if you have 3 different things you want to put them in order, then you have 3 things to list first, 2 things to list second, and 1 thing to list first. So we have to divide out all of the repeats. Al, Bill, and Chris is repeated in there 3 times 2 times 1, 6 different times. And so it would be 24 times 23 times 22, all divided by 3 times 2 times 1. Another way of writing that would be 24 factorial over 21 factorial. That is the same as what we had here. But then if we want to divide out the repeats, we're going to divide by 3 factorial, because that's the repeats. Or another way of doing the exact same problem is a combination. This is 20 of 24 students. We're picking 3, but order doesn't matter. So if it's a combination, then order doesn't matter in your awards that you're giving. So let's take a look at another situation. Here is another situation of a permutation. You want to elect a president, a vice president, a secretary, and a treasurer for your club of 12 members. Well, we can go 12 times 11 times 10 times 9. We have 12 people to pick from for president, then 11 for vice president, 10 for, let's say, secretary, and 9 for treasurer. That could be 12 factorial over 8 factorial, because the 8 factorial is going to wipe out like all the rest of them from the numerator. Or you can, from 12 people, it's a permutation. You're picking 4 and putting them in order, because president is different than vice president, and so on. And so that's a permutation. If we compare that to something very similar, but a combination, let's say you want to elect an advisory committee of 4 people from your 12 members. So 4 of your 12 members are going to go on to a panel and be an advisory panel to something else. And so now it's the same thing as what we had before. You can pick the first person from 12 people. Then once you pick the first person, you have 11 to pick from, and then 9 and 8. But if it's Al, Bill, Chris, and Dan, those 4 different people are going to be arranged 4 factorial numbers of ways, because order doesn't matter on this one. And so this is a combination. You could go 12 factorial divided by 8 factorial times 4 factorial, or you can just do a combination from 12 people. You're picking 4, and order doesn't matter because they're just going to be a group of 4 people going as a committee. All right, so now you have to decide what it is. So homestead lockers have 5 numbers. This is a picture of it. Have 50 numbers on the dial. That should be 50 numbers on the dial. How many locker combinations are possible? Assume that you can have a number repeat twice. So your combination could be 45, 45, 12, or 36, 12, 36. So we have 3 different numbers in our locker combination. We have 0 through 49, so that's 50 different choices for the first one, 50 different choices for the second one. Oh, we're going to assume that you cannot have, sorry, I said that wrong earlier, you cannot have a repeat number twice. And so what that means is once we pick our first number, that number cannot be repeated. And so this is not going to be 50 here. What this number is going to be is 49 numbers left for our second combination, our second number in our combination, and then 48 in our third combination. So we could go 50 times 49 times 48. We can also do that by taking 50 factorial over 47 factorial. Okay, or because because order matters in there, we're going to select from 50 numbers. It's going to be a permutation, and we're going to pick 3 of them. So I don't know why they call it a locker combination, because it's really not a locker combo at all. It should be a locker permutation. It should be your locker permi instead of your locker combo. Let's take a look at another example. So Grant gets ready for his big date by selecting 5 roses out of a possible 15 at a local floral shop. And he wants to present them to the lucky young lady that he's going out with. And so we are going to select 15 roses. We have to decide whether this is going to be a permutation or a combination. And it doesn't matter what rose he picks first. He's just going to pick 5 of them. So it is a combination. He's picking from 15 roses, and he's selecting 5 of them. Okay, so we could do it like this. If we wanted to do it the long way, it could be 15 factorial divided by 10 factorial. But then we'd have to divide that by the number of ways those can be repeated, which is 5 factorial. And so, not sure what that ends up becoming, but this would be a combination. And let's take a look at the last one here. Grant then selects his 5 favorite love songs to put on a CD out of a possible 15 he knows that she likes. So he puts them on a CD in a particular order so that he can play his love music song on the track on the radio when they go to whatever it is they're going to go to on their date. So does the order matter? Well, it does. He wants to have the first song first, and so this would be a permutation. He's picking from 15 songs, and he's picking 5 of them. So this is a permutation. We could also do this like this. He has 15 songs to choose from for his first song, and then 14, and then 13, and then 12, and then 11. And he could just multiply those together, and that's the number of orders that he can put those songs in. Or he can do it as 15 factorial divided by 10 factorial, because the 10 factorial will wipe out the rest of them that are in the 15 factorial. And so again, this is a permutation because the order that the songs are in makes a difference. Hopefully this makes sense, what the difference between a permutation and a combination is. The easiest way I think to remember which is that your locker really should be a permutation because the order that you put those numbers in makes a difference. So that's what your homework assignment is on for tomorrow. Good luck on that. We will go over questions that you have tomorrow in class.